Welcome. This session is called What to Accept When You're Accepting, and from the Los Angeles area, Esther Naum.
Thanks, everybody. Technical difficulties. I'm going to be reading this without my speaker notes, so hopefully I'll get everything. I'm covering exception handling today. There's a lot to cover, so I'm going to go pretty quickly. Just to introduce myself, who am I? I'm a Python developer from Los Angeles. I work for Cars.com in Santa Monica. I went pro in late 2011. I've been a hobbyist since then. I have no CS degree, so I was largely self-taught. You've probably met me if you were in the LA area at LA Hackathons or at PyLadies events or LA Girl Geek dinners, which I help to organize. In this talk, I'm going to first go over what exceptions are, how to handle exceptions, some best practices and things to avoid. We'll talk about exception handling as it's done in Python in particular. And then if there's time, I'd like to just expound a little bit on defensive coding and the idea of coding defensively, whatever that may mean. So what is an exception? Well, I'm sure you've written a program where you have something that is supposed to return an expected output. So if we square this number and we enter 3, it gives us back a 9. If we give it an input that's not correct, then we'll get this error message. And it's really frustrating when we see this, usually because we don't know why it happened. But what you'll notice is that the reason why we get an error is because the function's assumptions about the inputs that you gave it have been violated, right? And in the error message, you'll find actually a lot of information about what actually happened. First, you have a traceback. You have the kind of error that occurred. And then you have an informative error message, which in this case tells us why this error occurred. And this is an argument that's passed into the exception when you raise it. So you have all this information about the error packaged up into an object. That's what's great about Python exceptions. Taking a look at this other example, let's say I want to make a sandwich, right? So I'm going to add the meat, add the cheese. I have a couple functions that will give us a sandwich in the end. But let's look at the add meat method. Well, if we're checking to see the property of the sandwich, the meat property, and if it's either ham or beef, we're going to raise a value error. So in this time, we're causing the exception to be raised right there. So if we were to try to make a sandwich, and we make a sandwich, and we say that we want to make a ham sandwich, it's going to give us the error that we raised, a value error. Now, what is exception handling? Well, taking a look at the sandwich method again, we're going to put the add meat method in a try block. And if we happen to get a value error, then we're going to print this message out. What's nice, though, is that it's after we print the message, we can still add the cheese, we can still add the pickle. So if we were to make the sandwich this time, well, we'll get a message back, but we still have our sandwich. It didn't throw us an error. You can see we're still in the interpreter. And if we check the type of the sandwich, the meat of the sandwich, we see that it's none, just like we'd assigned it in that method, in the add meat method, right there. So what causes exceptions? Most of the time, believe it or not, you make mistakes when you write code. It happens. Sometimes people reuse your code, or you even reuse your code, and you might do it in a way that the code receives an input that it didn't expect to get, because it makes certain assumptions about the inputs that it's going to receive. Sometimes it's client code errors. When you use other frameworks or other libraries, you might pass it an input that it doesn't expect, and it's going to raise an exception. Sometimes there are low-level hardware failures, for example, like a connection dropping or you run out of disk space. And in a lot of cases, just exiting the program might be preferable to compounding the errors and if you were to continue after an exception is raised, you probably want to exit the program altogether rather than risk continuing working with bad input and bad output. So you might be asking, why not just use error codes, right? This is what people do in other languages. So one of the issues is illustrated in this example here. So let's say that we have an error code that we say, okay, -1 means that we have an error. If any function returns -1, then we have an error. So in this A method, we have a value that's set by calling B. If we get back this error code, then we're going to barf, right? So let's look at the B method that's being called by A. And we see that the B method calls the C method to get a value, and if there's an error in the C method, then we're gonna barf, right? And let's look at the C method just for fun. I just make it return an error all the time. Well, what's gonna happen is that, if C returns an error, then B has to know how to handle the error, and then A also has to know how to handle the error. So what if you did something where you wrote another function in between B and C? Whatever comes between B and C is also going to have to know how to handle the error. And after a while, this just adds a lot of complexity, and it leaves a lot more room for bugs. Whereas if you just had an exception, let's put the call for B in a try block, and have it handle any value errors that are passed up. Okay, so we call B, and B calls C, and C returns a value error. Well, B doesn't have to handle the error that's passed because it's just going to propagate up to the caller of B, which is A, and A does have an exception handler for value error. So it's going to handle the exception, and it's nice and clean, it's easy to read, you can see right there. The last thing you want to do is have to find yourself enumerating all different kinds of error messages, and then what if one of the values changes and now you're going to have to change all your functions to make sure that they can handle the error correctly, right? So why would you want to handle an exception? Like I said, sometimes you want to exit the program entirely before the mistakes compound. Other times the error might not be fatal. You might still be able to go on. If you remember the sandwich example, even though we had a meat sandwich, we were still able to add the cheese and just give them a sad cheese sandwich, and they were happy. So what kinds of exceptions can I catch? In Python, an exception is a subclass of the class base exception. So you can see there are other kinds of errors that can occur, but the main one that we care about right now is the exception class. And if you look in the docs, don't try to read all this. This is a basic tree of all the subclasses of exception and their own subclasses as well. So these are the kinds of exceptions that you can try to catch and to handle. So who should catch the exception? Let's think again about where breakages occur. Again, they might happen in your application, they might happen in the framework, or at the system level. So maybe you're thinking, well, why don't I just try to catch all the exceptions in a bare except, right? So we have this query in a try block, and anytime there's an exception, we're going to handle the error. Well, if you remember, a bare except clause will catch all instances of base exception. This includes system exits, keyboard interrupts, and generator exits, which you'll find out later you probably don't want to be catching at this point in time. You can make it a little bit better by accepting just the exception class, right? So now you're only catching all those subclasses of exception. Let's look at this example again. When we run the query and we try to catch an exception, we're going to try to handle this. But if we look at the run query method, you can see it does a couple things, including a call to connect to DB. And this call is going to raise a database not connected error. Well, what happens is, if you find that the error is raised in connect to DB, it's going to bubble up all the way to the try except block, and the accept exception will catch that error. But you really want to ask yourself, is that where you want to handle a database's connected error? Right? You're running the query. Why not try to handle it in the run query itself? So what if there's more than one possible exception that can occur? Well, you can you can add two exceptions into your except block. You have to make them a tuple. This is due to changes that are going to be happening in Python 3. But so if you have something in a try block, you can try to catch exception A or exception B, and if either of those occurs, then you'll be able to handle them. Any other exceptions are just going to be ignored or passed up to another handler. You can stack exceptions as well if you want to handle them differently. Let's say that one of the exceptions that you want to catch is something that you could sort of handle and then move on and continue with your program, but the other one is so serious that you just have to exit. Then this is how you would do it. You can even catch granular exceptions. So when you're writing code and you have something in a try block, you really want to handle the exception that's closest to whatever's in the try block. You don't want to handle errors that are more general, like we said. You want to let them just bubble up, or to nebulous, I guess. That's the same thing, isn't it? But you'll see here, zero division error is a subclass of arithmetic error. if we put zero division error in the first except block, then any errors that raise a zero division error we can handle. But anything that is an arithmetic error but that's not a zero division error, that'll just skip that first except block and it'll just be handled by the arithmetic error block and be handled that way. What if you want to catch lots of exceptions? You could probably try to handle them all. I would say that this is kind of a code smell, right? You might want to rethink your inputs and think about why you want to handle so many different kinds of exceptions in your code, especially if you only have like one thing in your try block, right? So now that you've caught an exception, what are you going to do with it, right? Some people just, I've seen code that just passes the exception, kind of continuing as though nothing went wrong, okay? But then at that point you have to ask yourself, why do you want to just pass on an exception that you just caught? Isn't an exception something that's exceptional? It's something bad happened that you weren't expecting. Why would you want to just continue as though nothing went wrong? A key point to have in mind is that in the end, exceptions are always handled. If they're not handled by the block in which you're trying and catching the exception, they're going to be handled further up the stack, in places that you might not want to be handling the exception. They might just end up throwing an error and stopping your program in its tracks. They might lead to a business failure, right? And so your boss is going to get really mad and ask you, why didn't you take care of this bug and fix it or handle this problem? And the farther away that you are from the code that's buggy, trying to debug it, then the more costly it will be to fix. So always think about, if you're going to be catching an exception, think about how you're going to recover from that exception. So at the very least you can do, right, is to use a logger to log the error. The Python standard library has a great logging module, which you should go look up and make use of and learn, make it your friend. Logging will help you debug your program so much faster because you'll know when and where things went wrong, right, especially with the traceback information that's raised by the exception, that's passed by the exception when it's raised. Another thing you can do is to just delay the exception. Let's say that you want to open a file and you want to read the file and you find an exception. When you open a file, you really want to make sure that you close the file before you do anything else. And so you might call the cleanup method and then maybe log the exception, say something went wrong, and then raise the exception like this. So this raise statement is interesting because if it's just a bare raise like this, it's going to raise the same exception that you just caught. Right, so this is going to raise an exception. You could also retry an exception. So here I have the try except block in a loop. I'm just going to try to connect to the server. If I can't do it, then I failed. But this at least lets you continue until you can't anymore. You could even try re-raising an exception. So something bad happened. So this is one of the only times where having a bare except might be okay because you're at least raising the exact same exception object that you just caught, and so you still preserve the traceback information and the type and any arguments such as an error message. If you were to catch a specific exception and then raise an exception, but you specify the name, like here we're catching a value error, but we're raising a value error. What actually happens is this raise statement is going to create a new exception object. Basically what that means is you lose the traceback from the original exception that was caught. So this is something to watch out for. A lot of people forget about this. If you're going to catch an exception, make sure that if you're going to raise either the same exception class or even a different exception, make sure that you also preserve the traceback somehow in the arguments. I can't get into that right now for lack of time, but it's all in the docs, so you can look that up. So like I said, you could raise another exception. If you caught an I/O error, for example, you might want to, you might want to catch that error and then raise a different kind of error, something that, if you write a program and it has a specific kind of exception, but you're calling it from another part of the code, well, maybe that part of the code doesn't know how to handle this specific custom error, but it knows how to handle and deal with the value error, so you might do that. Again, remember to preserve the traceback when you've got this. But why would you want to create your own custom exceptions? I hinted at this before, but you want to be able to isolate exceptions that were caused by code in your application, for example, from exceptions caused by other code that you're using. So that if an error pops up while you're running a program, it's a lot easier to debug and know like where specifically the error happened. Was it your fault? Was it somebody else's fault? It's helpful. So just going back to the Sandwich example, I'm going to create a custom exception. All you have to do is inherit from the exception class and just name it what you want. And it's really easy. If all you want to do is create your own custom exception class, then you just run pass. What's even better than subclassing from exception, though, is if you look over here, there's a whole bunch of errors that are subclassed from exception. They're a lot more specific and therefore a lot more informative. So I'm going to pick value error here. The reason for that is because if you remember the Sandwich example, we're looking at values of meat that have the right type but an inappropriate value. I find meat-filled sandwiches to be inappropriate, so that's what I'm going to do. I'm going to subclass from the value error exception class. You can even make granular exceptions, right? So just like value error is a subclass of exception, I can make a meat exception that'll handle exceptions specific to the getMeat method, for example, and then subclass that from Sandwich exception. So let's go back to this function. So we put the sandwich getBread and getMeat in a try block, and we want to handle a sandwich exception. So let's look at our getBread method. You'll notice that this raises a value error. Okay, so what's going to happen? This exception handler here, Sandwich exception, is going to catch it, and it's going to handle that exception. I'm sorry, this raised a value error. It's actually not going to, I'm very sorry. Okay, this is actually going to bubble up because Sandwich exception is a subclass of value error, and it's going to just bubble up to something that can handle the value error. Another reason why you might want to customize exception classes is because you don't want to expose the implementation details of your program. So taking a look at the Sandwich method again, I really like sandwiches. In the getBread method, let's say that we're calling getBread, and we're using a specific kind of bakery. In this case, it's the New York Bakery, and we know how to handle a New York Bakery exception because we have an exception handler here, but we're going to raise a sandwich exception, and this is something that the makeSandwich class can understand. If we were to change bakeries, then again, we have a method that can handle the bakery exception, but we don't have to change anything in the makeSandwich method because it already handles the sandwich exception and it knows how to deal with that specific error. Another thing to know about the try-raise syntax, try-except syntax in Python, is we have an else statement. You can do this if you have code that you want to pass through the try block, and as long as it doesn't raise any exceptions, you want to run something, assuming that the flow of the program hasn't been interrupted. And so it's not common to be used, but it's very, very useful if you do need it. There's also a finally clause. The finally clause is executed no matter what. Whether or not you catch an exception, whether or not it flows completely, it's always going to be executed. What happens is if you were to try opening the file, and even if an exception occurs, it's going to run the line in the finally block, and then it's going to re-raise the IO error that was originally caught and raise that as your exception. So this is also a very useful clause. There are cool things you can do. I actually don't have time to go into the intricacies of the context manager here, but the context lib library in Python is very, very useful for encapsulating exceptions. Let me show you just a really quick example. So let's say you have something in a try block and you handle the exception, you have the finally there. If you were to write a couple functions that did exactly the same thing, it gets a little repetitive. With the context manager, it looks a little bit more complicated because you create this context manager decorator, and you have the try except finally blocks in the try this method. But if you look at my function, you'll see it's a lot cleaner than the original code that's in the try except finally block. And what's nice about this is you can use the try this in other functions that you write. So yeah, get to know the context manager. So exception handling has a couple of connotations specific to Python. I think one thing that people think of a lot is the whole look before you leap philosophy versus the easier to ask for forgiveness than for permission philosophy. This is mainly connotative of the ability of Python to do duck typing, right? If you were to try to check if something contains an instance or has a or is a or something, it gets kind of old. It's not very nice in Pythonic code. It's better just to assume that something is able to do something, and if it can, it raises an exception. It's a truly exceptional, unexpected occurrence, and you can handle it, and it's clean and it's fast. You might be interested to know that a couple of Python methods actually make use of this ability of handling exceptions. For example, the iterator knows when to finish when it raises a stop iteration. So if you've ever used a for loop or anything like that, then as soon as you reach the end of a sequence, what really happens is that your iterator has received a stop iteration error, and that's how it knows it's done. Same thing for the get item method. It raises an index error exception, and it handles it, and it's very clean and it's very nice. So in the last 5 minutes, I just want to go over ideas about defensive programming. This is sort of what caused me to think about proposing and writing this talk in the first place, because I was sort of interested in how people learn how to expect the unexpected. As a programmer, I think your job, something that comes to occupy more and more of your life, is looking at code and even looking at other things in real life and seeing how you can break it, seeing how things can go wrong, so that you can be able to fix it without things leading to catastrophic failure, right? One framework that I found really useful, and of all people, Donald Rumsfeld inspired me to think of this, but you have what are called known knowns. And so if you remember what I said about the iterator, you've got a known known. You know you're going to reach the end of a sequence, you're going to raise an exception, and you know how to handle it. You stop, right? You also have known unknowns, which are things where are probably going to cause an exception, but you can expect them, so you're going to be able to handle them. So like dropping a connection, you know that's going to happen. You might have unknown unknowns, which might be caused by bugs in your code. You can't know that you have a bug in your code until you have a bug in your code, so there's no way you can really handle that. That's probably the most frustrating one to deal with, but that's life. The most insidious one, though, is the unknown knowns. These are things where you make an assumption about something, but it turns out to be false. So something about your input, you assume that you were going to receive an integer, but somebody somewhere uses your code and enters a string. That's something that you might have to anticipate sometimes, and it's really frustrating, and it's really difficult to figure out how to fix. So a couple of ways to sort of mitigate against these problems. The first is, again, to think through your assumptions. Remember that every bug is two bugs, right? One is a bug in the code. The other is the test that you didn't write for your code. What I'm saying is use testing, right? How do you know that you've anticipated all of the necessary exceptions? You could test your error handling. Learn and get to know the assert raises statement when you write your unit tests, right? And just remember that in the end, all exceptions are handled, right? So it's just a matter of when, where, and how you're going to accept them, or who. Is it going to be you? Is it going to be your boss? Is it going to be a user? So just be aware of that. Just some acknowledgments. Thanks for my employer, Cars.com. We're hiring, by the way. If you want to learn more, I could spend all day talking about exceptions with you. If you come out to sunny Santa Monica, just want to thank these other people. If you want to ask me more questions, you could find me under this username on those places. So that's it.
Okay, we have time for questions. We've got a microphone here, or otherwise come over here and I'll hand you this one.
Hi, on one of your slides you had a try block, and then you had two accept blocks where one was subclassed and exited the program and the other didn't.
Right.
If the first exception had not exited, if they both handled it, could the two accept blocks ever both execute, or does a try block correspond, does it run exactly one accept?
That's a great question. The code is run just once, so if the exception is handled once, then it's not going to rerun whatever's in the try block. Yeah.
Any other questions? Don't be shy. Oh, there we are.
A lot of times, the first time I write my code, I try to code defensively and do the try except everywhere I think I need to handle whatever API I'm calling. But the first time I write it, I don't know what exceptions it's going to throw, and there could be a lot of them. So let's say I want to try to delete a file, and I say, okay, well, I look up their API and I see, oh, the file doesn't exist. This is the exception, so I catch that. But then it's like, oh, I didn't have write permissions. Oh, or something else happened. So what ends up happening in my code is I just end up with a lot of accept exceptions because I don't know the 4 or 5 different ones I need to catch. So what's your recommendation for finding out, how do I find out what exceptions they're going to throw that I need to catch?
Okay, so I think the question is, if you're running a code from a library that you're not familiar with and it throws an unknown exception that you just didn't read about, or even if you read about it, it's not what you were expecting, so you're not sure how to catch it specifically, how you handle that. I actually think when you're debugging and stuff, you probably don't have a choice but to start with a bare exception and just work your way through until you figure out what you're doing. You probably don't want to leave that in production, though.
Right.
Yeah.
All right, we're out of time. Thank you very much.